So we'll find out here what happened and some of the issues with this type of automation complacency that occurred in Air France 447. Over-reliance is one of them. Disregard for the evidence and losing skills. This is one of the big issues that the FAA sees with automation and also with the telemedicine aspect as well. Trusting more the robot or the system over top of the cognitive element of the brain and the skills that you've gained and the experience that you've gained over a lifespan. Um, this is really a big issue, and the FAA has started to do a lot of studies on automation complacency and something also called, to formerly in my area of expertise, is automation addiction. How do we remove the error? Well, simply adding a computer is not going to remove any type of error. Sometimes adding computer and automation systems can induce actually even more error. The higher the automation authority, the more feedback we need. This is one of the things that happened in Air France 447. The ACAWS, advisory cautions and warning system, really probably wasn't giving the pilots the right indications they needed to adequately address the malfunctions that were occurring with the aircraft system. So feedback is extremely important, and then making sure once you get that feedback that you don't have this automation bias where you just assume that the computer is smarter than you are and you're taking an active role in determining the outcome of the situation that you're in. And this is really important in training and also important at the design level. Automated systems really has four stages: the acquisition of information, displaying that information, decision to be taken, and then implementing an action. So the analysis piece is where the feedback occurs, decisions is where you're arriving to a solution, then eventually implementing that action. When I was talking about before of detecting the right problem, you want to make sure that the decision piece, that is a shared responsibility, that third block between the computer and the human. If the computer has all of that responsibility and decision making, you as the human will just implement the action and it might be the wrong action. Learning and automation. Again, feedback, and this plays into the decision-making process. The problem solving should be occurring in the human brain and not necessarily in the computer. The computer is there to help you learn and understand. What's important in the design aspect here is a shared vocabulary, sufficient knowledge, and input and a review of the tasks. So there has to be some shared vocabulary and knowledge between the computer that's operating the system and the human. If this doesn't happen correctly, and really can be also a design issue and a training issue, you'll have problems operating the automated system and become really complacent in the system where you're just always assuming that it is correct. Education certainly plays a role in automation. We see this with video game systems and military systems. It's driving a higher demand for automated systems. Students become bored pretty quickly if it's a traditional classroom setting. The younger generation is certainly understands these net skills or internet skills, but they're also prone to automation bias, probably more so than the older generation, because they are always going to assume that the output is always correct. Example, Googling. I just Google a question, it gives me a response. I don't think about it, I don't analyze the response, I just assume that's exactly what the answer is. And that's where that automation bias really is prone to the younger generation of people. The military has a lot of automated systems, and probably one of the industry bases that's really pushed automated systems with full glass cockpits. Picture over on your right is the glass cockpit simulator in the F-35 Joint Strike Fighter, which is the next generation aircraft system, manned aircraft fighter aircraft for the Navy, Air Force, Marines, and also internationally. We also have unmanned aircraft and unmanned ground vehicles, which I work a lot in, and both are extremely highly automated systems. The aircraft picture on your left is about the size of a 737. The aircraft can fly anywhere in the world 24/7 and is controlled stateside via satellite and other communication links. It auto lands, auto takeoffs, it auto performs emergency procedures. So lots of interaction between the computer and the human, and a lot of authority in the computer. And the same for unmanned ground vehicles, which is really starting to make a place in military and is driving the commercial sector, which is automotive automation. BMW, Mercedes, Lexus, and Google are all researching with this. And what's really driving this is radar and LiDAR technologies. Light detection and ranging technologies is driving this technology. LiDAR uses lasers. And what's really difficult about the ground vehicle piece, unlike the airspace piece, is that in air, all you have to be concerned about are other airplanes. There's not too much else to run into up there. But on the ground, it's a very, very difficult problem. It takes a lot of microprocessing, a lot of sensor data to correlate to be able to have in a fully autonomous ground vehicle. There's very little data available on this, on how safe it is or what's coming out of it, if it's going to be feasible or not. It's really a lot of studies that are occurring. So stay tuned to see what happens in this area. Let's watch a quick video here on the Google automated car.
Good morning, Steve. Hey, Nathaniel. How are you? Doing just great. Go ahead, Steve.
Auto driving.
Here we go. Away we go. Look, Ma, no hands. No hands anywhere. No hands, no feet. No hands, no feet. No nothing. I love it. So we're here at the stop sign. Yep. Car's using the radars and laser to check and make sure there's nothing coming either way. I find myself looking. Old habits die hard, man. They don't die. Hey, anybody up for a taco? Yeah. What do you want to do today, Steve? I'm all for tacos myself. All right. Well, let's go get a taco at the drive-thru. And we're turning into the parking lot. How neat. There we go. Now we kind of creep along here. Does anybody have any money? I've got money. No, I've got my wallet right here. You roll down your window and order a burrito. Yeah, push that. I'm doing very well. How are you today? This is some of the best driving I've ever done.
So I just wanted to show a short clip of that. And one thing that I saw was really interesting is he comes to the stop sign and the guy on the right says, old habits die hard, and he's looking for other traffic coming. Well, this is an absolutely perfect example of automation complacency. So if you're always relying on the automated system in the car, you're probably going to stop practicing that skill set. So what happens when something fails in the car and you don't look left or right and the car just moves out into traffic? You have a collision. This is the biggest issue with automation and automation complacency. In conclusion, automated decision making has its advantages. It certainly helps the human with the workload piece. As we mentioned before, you can only do so much work per unit of time. However, we can see that there's some overconfidence occurring in automated functions and automated systems. It certainly does not replace the human. The human is still a vital part of the automated system. We saw this in Air France 447. This comes into training and design and understanding the responsibilities of what the computer is doing and what the human is doing, and practicing that skill set and making sure you still have some tactile and problem-solving skill set to be able to address issues as they arise. One of the biggest questions is how are we going to balance automation and human control? This is a hard one, and I hope to research this more as I move throughout the doctoral program. I believe there is a balance. I'm certainly not in the camp that it's all 100% automated control. I'm not sure if we will ever get there. There may be some commercial applications that the public buys into, but I have a hard time believing that it will be with any type of machine operating systems where they're so automated that the human has no control. And finally, the verse takeaway, through him all things were made, without him nothing was made that has been made. So it doesn't matter how much automation comes into play, it's still up to the human. The human is in control. Thank you for your time.